Thank you. And one quick comment about the headsets. If it is blurry for you, there is a wheel at the top you can turn to adjust for your eyes. So thank you for inviting me. My name is Michael Antonov, and I'm one of the co-founders and the software architect at Oculus. Today, we'll be talking about bringing virtual reality to the world and how we built it at Oculus. So some of the things I'll talk about are just a bit of what virtual reality is and what's exciting about it. We'll also talk about what it took to actually start the company and some of the technical and business challenges we faced, and maybe some things which I've personally learned from that. And then we'll talk about virtual reality and augmented reality future, which is very exciting indeed, and some of the ways you can develop for it. So first question, what is virtual reality? You can think of it as a computer-generated simulation or a 3D world that can be perceived as real. So when you put on a headset, you can interact with it in ways which are real or similar to what you do in the physical world. So it's kind of a little bit like this, where you could put in all this hardware on your face to cover your view. And hopefully, when you move right and left, it will be appear realistic. So to do that, what you really need to do is fool your senses. So there is 5 basic senses that you normally have. There is vision, sound and hearing, smell, taste, and touch. Now, vision and sound is what we actually work with a lot, and we kind of got our grip on. And with vision, you can use GPUs and graphics and screens and magnifying glasses to cover your field of view. The senses of smell and touch have been challenging. Some people have tried to make smell generators, but in the end, it's kind of hard to get the smells out of the room once you've actually generated them. So it's not such a big, I would argue it's not really quite as important. Touch, on the other hand, is something we would really all love to get better at. Right now, you can have mostly vibration and controllers, which provides a little bit of feedback. So for example, Oculus Control will have vibration when you reach to an object. Of course, we would all really love to be able to reach out and touch the real world, so you can feel the pressure feedback. But there's really no good commercial solutions to that yet. It's something which hopefully will come. So as I mentioned earlier, covering your vision and dealing with it and representing it correctly is important to achieve something we know as a sense of presence. To do that, you have to have your head motion matched really correctly with the real world. And then, of course, if you want to be able to reach out and grab an object, you have to track your motion of your hand as well, so you can interact with things in a real way. We've been able to get to achieving that with the Oculus Rift headset on a PC. In that world, you can pick up objects and you can manipulate them. And let me tell you, having your hands in VR really is a magic experience. It makes a huge difference, because usually I've seen people who won't put in and they have a touch controllers, and they're amazed by being able to interact with it in such a way. Now, another product which we have is Gear VR, which I'm passing around. And the benefits of it is it's lightweight, it works from a phone, and it is wireless, which means you can take it anywhere. And while it may not yet have all the reach-out aspects, it can still create really compelling 3D environment. So you can see and you can look around. And you can have some really good games. Now, one of the reasons the world is getting excited about VR is the full range of experiences that people can have. So even though it started with games because it was the most obvious initiative, there's a lot more you can do. You can do architectural visualization, where you could see the buildings before they've been constructed. And that can really give you a sense of scale. There's really nothing which can replicate and see what it is like to be in a place by just doing it on a 2D screen. It's so much more real in VR. You can do training, whether it's medical or industrial. You could also communicate. And this is an area which we are very excited about, because the ability to bring a person right next to you who's actually on another continent is something which you'll ultimately be able to achieve. So now you kind of know about VR. I'll talk a little bit about my story and also the story of Oculus. So for me, it started with programming. And that's actually a picture of me back in college days. And I personally started programming on a graphing calculator, which you see right here. It's TI-85. I came from Russia with an immigrant family. We didn't really have much money. So I could not afford a computer for like several years. So the calculator would allow you to program in a language similar to BASIC. And it would do black and white graphics. And you could draw graphs and so on. So that was kind of my learning experience. In the end, I did get a computer in the college, and I stayed up late nights learning assembly language in C. So that's actually what got me into computer games. Because I love games, but more than that, I wanted to make them, which kind of led me to learn the computer graphics and systems programming. So now, in college, when I got there, I met a few guys. And if you see in picture, there's actually on the very left, that's Brendan, my best friend and business partner. In the future, he will be the CEO of Oculus. So this is a picture of us in our first company called Scaleform. We wanted to make computer games. And Silicon Valley has these stories about people starting in a garage. In our case, it actually was in an old bank. We found this, actually Brendan found this old building which used to be a bank. And it literally had wires hanging from a ceiling. It was kind of dark. There were some old boxes in the back. But this Pakistani guy rented it for us for dirt cheap. So we sat there in front of computers programming. And what we actually made was a tool for computer games. Well, we wanted to make a tool which would make any games, perhaps like Unity or an Unreal Engine today. We really underestimated what it would take. So in the end, what we made was a user interface technology. Essentially, we made menus and things which went into computer games. So you can sort of see that you can make screens which rotate and position in space for scores and so on. Quick question, is it possible to make this lighter? It's kind of washed out. Maybe we can switch off the light, I don't know. So this company actually took a very long time. When we started, we didn't know how long it would take. So it took about 5 years to get the first customer. So I remember my mom called me up, and she was like, what are you doing? You should go back to school, finish up, get a job. I had friends who got apartments and moved in. And I was sitting there and programming this thing. So it was kind of tough. But in the end, we got our first customer. It was this company called Firaxis Games. And it was actually a game called Civilization 4, which was the first of our product. Now, that was actually a turning point. After that, we were able to get more people on board. And it actually ended up being arguably the #1 user interface technology in gaming. So in about 10 years later from starting, a very long time, we sold the company to Autodesk for $36 million. It had about 30 employees. We had our ups and downs. And we learned some really good things. So what were the lessons from Scaleform? In fact, I believe having done that was critical to building Oculus later. So first lesson is building complex software systems takes time. In our case, too much time, or many people and an involved software organization. That simply means that it's hard to estimate projects, and you have to be realistic about what you expect. Another thing which is important is release early and iterate. You want to get your products into customers' hands as soon as you can, and then start to make them better. In our case, for the first 4 years, we had no customers. That's not the best way to start a business. You can learn from that, but you want to do quicker. Focus on products that customers want. It's very basic, but sometimes it's just too exciting to build something you want to build, or what you think they want, and you're not actually asking what they want. So it's like business 101, but that was critical. In fact, in Scaleform, we had to pivot the whole company and change our product from one to another before we became successful. Keep going through the tough times, but be willing to change. Perseverance and keeping at it makes a difference. And at the same time, you have to always think about what is it you're doing and how it can be adjusted. And finally, having knowledge, experience, and industry contacts doesn't hurt. That's very basic. If you are starting a company and you don't have some of these things, try to have someone join who does. So now, let's talk about Oculus. Compared to Scaleform, which took 10 years, Oculus was moving really fast. In fact, we certainly stayed up our late nights, and it was moving, and lots of things were happening. But in fact, sometimes it was happening so fast, we called it the rocket ship. So the question was, do you want to join the rocket ship? That's one of the jokes we sometimes make when we bring employees on board. Now, it all started with a 19-year-old guy called Palmer Luckey. He is the guy you might have known. He used to wear flip-flops, since he still does. He loved collecting VR headsets, and he was making them out of foam core and duct tape. You can read about him online, so I won't go into much details. But long story short, he made a first headset out of duct tape, phone screen, and some magnifying glass lenses. And this headset would cover your field of view. And when I first put it on, I saw this scene. It was kind of like pipes and brick, and you could hold it and you look around, and the world remained stable. I could see full things in 3D. And further down in an example, there was this kind of a pipe. You could look down, and it was kind of like a cliff drop-off. So I looked at it, like instinctively leaned back because I felt a sense of vertigo. I was afraid to fall down. And this actually was what inspired me to start this company and be involved in it, is because I believe that it's something that other people would want to experience. So one of the things which Palmer wanted to do was launch Oculus on a crowdfunding company called Kickstarter. It's essentially a site where you post your projects, and you set a limit. You can donate some amount of money, and you need to reach a certain amount before you get it. So the way it works is if you reach that limit, then you get all the money, and you can build your project. And if you don't reach the limit, then you get nothing. Our limit was $250,000. So at the time, it seemed like a lot. So I was kind of concerned that it wouldn't make it. Now, the amazing thing is that when the Kickstarter launched, we passed it within the first 2 hours. So if you haven't seen a Kickstarter video, I recommend you go online and watch it. It has a good story to it, and it's fun. So in the end, we ended up closing at more than $2.4 million. And we had 7,000 units we had to make. So you may wonder, why was this Kickstarter so successful? It was probably one of the top hardware Kickstarters at the time. It's hard to tell exactly, but here are some of the reasons I think that mattered. One was that it had technology people wanted to believe in. Many of us have seen sci-fi movies with virtual reality. So being able to do that, it really inspired and it touched people. and it was available at an affordable price. $300, it's less than you spend on a mobile phone, in many cases at least, and many people who really believed in it could just go out and get it. And it had industry superstar endorsements targeting for game developers. So we had people like Gabe Newell for Valve, John Carmack, Cliff Brzezinski from the Epic Games, Michael Abrash, David Hegelson, CEO of Unity, come out and speak in a video about how exciting our product was. That made it very interesting to the game developers, who were our initial target market. So having a particular market and people said good things about it was good. Finally, we did make a good quality video with a really good story. Palmer, a 19-year-old, creating this headset was really exciting, and it was made in a fun way. And we also had an active community engagement. If you think about it, we had Kickstarter, blogs, news. During a month's campaign, we had probably 15 articles come out just from us on Kickstarter, many more online. And we also had trade shows. So we went to Develop in Europe. We went to QuakeCon, showing off the headsets. So people were actively engaged as it was going on. So of course, now we had to build a company and ship 7,000 units. We could not exactly make it at home. Like originally, if you ship a few, you can make it and you just send it. This is enough volume that suddenly you need manufacturing. So you need to do a few things. Build a team, hiring key people for things like software development, mechanical, electrical engineers, operations for the business. We had to make the software work. This is an area that I worked on. So basically, sensor fusion for gyroscopes, distortion correction for optics, so the image is not bent, engine integrations, SDK for programmers to access it. And of course, we had to do engineering and manufacturing. Electrical design, sensor firmware, mechanical, and optics. And a big one was actually working with China. We had a company we reached out to called Burway. A gentleman who was also a co-founder of Oculus called Jack worked with them earlier. They made a Guitar Hero controller. So he had the knowledge of how that relationship can work. And that was very challenging because they've done a lot for us in terms of original manufacturing and engineering. And having that relationship was very important. It was also hard. Because if you go to a manufacturer and you say you're going to make 7,000 of something, like, we want 700,000. Well, we had more sales later on. We had 40,000 kits sold. But still, you need to have someone you could trust and work with closely. So that's very important. And shipping and logistics. If you actually ship something worldwide, and Kickstarter was worldwide, it's fairly challenging. There's costs and operations you have to consider. So that's what was our first product, Oculus Developer Kit 1. Few good things about it. It was for developers and not consumers. That's actually very important because it gave a very specific market and it set expectations. So people were willing to take some things which are imperfect about our product because it was in an early stage. Good things about it were that it had good field of view and low cost. Performance, comfort, you can look around, everything was stable. The downsides, a weight resolution, very blurry image, but no positional tracking, meaning you can look around, but you can't move. So this was kind of the scene you saw inside of it, called Tuscany. When we shipped it, you were in a virtual room, you looked around, and you could walk around the scene. So now, with DK1 out, we had the next technical challenge. And this challenge was positional tracking. So in a regular headset, in Rift, you could look around. But if you moved, the world kind of like dragged with you right and left. So some people would not feel well when that happened. So we had to have positional tracking so you can look around the objects, and something would be in front of you. This could not be done with just gyroscopes and sensors, because while gyroscope tells you which way you're looking, or at least lets you do that, accelerometer is not precise enough. The data flies away. So ideally, we knew we wanted to have a device which would look out into the world and know what's going on, and have something called inside-out positional tracking. But it was also a very complicated software challenge. And we needed to ship a product within 1 year. So what instead we decided to do is have an outside-in tracking system, which is called the Constellation. And this is essentially, we had infrared LEDs inside the device, which were tracked. And the way it worked on the software side is you'd have these camera images from outside come in. You would find the blobs or the dots in the image. And then you try to figure out how you associate them with a 3D model. Once you map them together, you could reconstruct the position. You run a software algorithm called bundle adjustment, which lets you optimize the positions. And you get this pose, which you combine with accelerometer and gyro data for able to estimating the pose. Then you can use that to predict the future location where the headset is going to be when the image is displayed. So this is what we did, and it shipped in Oculus DK2. The few good things about it is improved presence, higher resolution, and had positional tracking. So it actually was amazing to me the first time we got it working, because we had this scene was like an image in front of you. I think it was like an Oculus logo. What we could do, you literally look around it from all sides. And I just kept tilting my head right and left, because it's just so fun to have something which is not there, but you can look around in it. So that was exciting. The hard part was it actually had about 10 times the software code. So this was starting to get complicated in computer vision. Entirely different from DK1. So then, that was April 2014, and that's the big news came. Oculus became a part of Facebook at $2 billion. Now, the exciting thing about this, you could say, well, that's cool. We were the fastest startup to get a $2 billion. And then, of course, you have a question of why. On several sides, on Facebook side and Oculus side. Well, one important thing is, it's kind of starts a trend of VR being seen as the new computing platform. You can realize you can have augmentation and which role it can play in the world. On the other side, we actually also were asked, well, why did we want to sell? So we're talking to the team. One of the biggest questions inside was actually, is this good for VR? Does it make sense for Oculus to be a part of Facebook? And there were very clear benefits. One was being a part of a big company gave us resources to grow the team and invest in R&D. We knew that the computer vision and tracking problems are going to be hard. They're going to take decades. Well, and also we wanted to have good price. So being a part of a bigger team gave us resources to have lower price consumer units, which meant more adoption, which meant more people using the technology. And also would give us resources for consumer manufacturing. In the end, when you go to a manufacturer, you want to make some units, you usually have to pay for them up front. That number can end up very fast. So having a company with resources to do that really helps. And finally, improve back-end infrastructure. Facebook has amazing investment in the internet, in servers, and technology, which we could leverage. There's a few other things which I think Oculus offered to Facebook. Now, this is not an official Facebook line. This is basically my opinion of the situation. But one thing which was valuable is industry-leading superstar team. So one of the things we did is we actually reached out to everyone in the game industry early on, and we hired some of the best and most talented people in the world. So we had engineers from Valve and other companies who were literally industry legends working for us. So the company knew that this is a team which can get stuff done. Another thing is momentum and social value. We were shipping fast. We had lots of online presence, and people were excited about our products. we shipped several versions of our product. Then we also had a partnership with Samsung. So Samsung ships tens of hundreds of millions of units of phones. So having a Gear VR partnership with them really made a big difference. So now, of course, with Facebook and Oculus together, we had to ship a consumer product, which means we had to build Oculus Store and platform. Well, you have a device. What are you going to run on it? You need to have games. You have to have experiences. And you have to be able to find them somehow. So this was very important. So we had to fund the content for the platform. So, and that's a typo. It meant internal development, partnerships, and industry support. So Facebook has invested hundreds of millions of dollars to make games and experiences all available there. And in the end, you wanted to have a high-quality consumer device. We wanted to have something which would be the quality of an iPhone. And in the end, it meant hundreds of parts, lots of engineering. And we wanted to have a touch controller, which would allow you to have your hands in VR. This actually ended up being a very hard project to make, because if you have something big, it is easy to track, but it's not convenient. So the solution we came up with was actually having LEDs in the ring. And the ergonomics on this, that's actually pretty awesome. But it was very hard to design. So this here's Rift with Touch. This is ultimately what we shipped. If you haven't tried it, I recommend it. I'm very happy with it. So now if we talk about a few more things which I believe you can learn from Oculus. First, let's talk about hardware. One of the things which people sometimes don't know when they do crowdfunding on Kickstarter is that raising money on Kickstarter is often not enough to ship a product. So you may be able to get enough money to actually manufacture the units, but then you don't have enough money to build your company, to pay salaries to people. Or if you spend on your company, then you don't have money to ship the units. So usually, you would need to have extra investment to be able to make a project pound. In our case, it meant from us and from venture capitalists later on. Another thing is manufacturing iteration is hard, especially remotely. And I think it'll be easier for you guys. But you want to have this really close relationship with the manufacturer. You could try something and do it quickly. But very often, it takes months or 3 months between the time you want to make a change to when it can actually make it. That's the process which we as an industry need to optimize. Another thing is shipping worldwide is complex and expensive. When we had Kickstarter, we listed it for you could pay $30 to ship anywhere worldwide. We realized it actually would cost more than $100 to ship it per unit. And I'm talking about anywhere. And we're talking about customs. We're talking, you go to FedEx and say, I want to send this box to, I don't know, Argentina. What are they going to charge you? $100. That's not something we could afford to pay. So therefore, we had to invest with smart ways of doing it, with logistics and distribution centers and whatever. So it's something we can't underestimate as a young company. Ship early and then iterate. This is kind of repeating what I've already said in some ways. But basically, if you can get something out there for your customers, in our case, DK1, and then do something later, it's usually a better approach. Because then you can get feedback, you can get your company off the ground. Active community engagement. Online media, talking to your customers. And a funny other point is, in a competitive industry, it is important to have aggressive growth. In our case, that meant hiring and aggressive execution. Because if you have a hot industry, the competition will come. I personally did not believe that there would be a competitive product such as HTC Vive coming out almost the same time. I thought it would take another year or so. And it has just come to show if something is exciting, others will do it. so you have to move. Another interesting question you might have is, what does it feel to be in a startup versus a large company, and what the pros and cons are? So I thought I'd share my perspective on the subject. So first, one of the good things about startup is you usually have a tight team, which is small, so you can make fast and empowered decisions almost immediately. It also means as an individual, you can, in that small group, you can make wide impact changes to the whole product, which feels good. But it also means you have to wear many hats. Like, as a software architect, I was responsible for buying computers, personally on my own credit card, probably first 20 people we hired. Of course, you get the founder motivation, which is exciting. And at the same time, you're operating often in this burnout mode. 24/7, 6-7 days a week, your work is your life. Now, often you'll also be cash-strapped. It wasn't so much a case for Oculus. It was a case for Scaleform. We had to miss, I don't know, I probably missed 30 paychecks in the first 4 years of Scaleform. And sometimes you get top-down management. And what I mean by that is simply the fact that startups are founded by entrepreneurs like you. Sometimes when we start, we don't have experience working with large groups of people or how to motivate them, which sometimes can lead to challenging situations. Now, in a large company on the other side, you often have the benefit of hiring money, stability, and resources, which means you can compensate your people well, and you can create conditions where they can work comfortably. You also have large teams, which results in more focused roles. So there will be a person whose job it is to design these buttons on the controller, and that's what they're going to be working on for 6 months. Now, the good thing is it means the buttons can be done really well. Some people may want some bigger role. So that often involves leadership. The other good thing is a big company that can do things right, just in terms of quality, and it has a process and structure, which kind of means if you want to buy something, you have to go to an IT department for hardware, things like that. The good thing is it does provide a way to build wide and complex systems. You would not be able to build Oculus the way it is we're shipping right now with a small group we had originally. There's just too much software, too many details, too many customer connections. It just couldn't happen. So you have to have a scale. And often, I don't know if often, but I think it is in case with Facebook, is that you can have people-focused management. This is my word, but the thing is, being a manager and a leader in a big company, or at least in Facebook, is about your people. So you're supporting them. They're not there to do things for you. I think that's a really fundamental and a really good culture change, which allows people to be happy on your teams. So now you know the history of Oculus. Let me talk a bit about next-gen VR and AR. You'll see that a big part of it is actually about tracking everything with computer vision. So recently at F8, Michael Abrash went in and talked about the future. And he said that ideally, what we'd like to get to is sunglasses. This is the future. 20, 30 years from now, we will be walking around with glasses, and the distinction between VR and AR will be gone. You'll be able to put them on, and you will see a world which is improved. You have 3D objects mixed into it. You will be able to access information which tells you anything you want instantly. You'll be able to bring other people into it. Now, of course, we are not there, and it will take a lot of work to get there. And you will need to address all these things to make it well. You have to improve optics and displays, understand user interaction, audio, vision, computer, system design. There's a lot to do. Now, I'll talk a bit about two areas which are near and dear for me are computer vision and AI. The reason I really like these is because, first, I'm a software person, and second, I feel like if we had the knowledge and the right software today, we can achieve a lot of the benefits today. We don't have to wait for some future hardware. So one of the things you want to do in VR is bring people and environments into it. So this means hands, head, environment. If you're there, I want to see the desk. I want to see you students in front, see the floor. And the software needs to know about it. And also about any obstacles so you don't run into things. So you want to be able to do that, and you want to do it without external hardware. Like, you don't want to have a base stations or cameras around. You want to have a device which comprehends the world. So the first step which we demonstrated to that was our Santa Cruz prototype. It was at Oculus Connect, and it used cameras to recognize and do positional tracking. So this is what I talked about, being able to not have cameras. The way it works, you don't need any external device. You have cameras on it, and it looks out into the world. And it can do something called SLAM, which is a technique called simultaneous localization and mapping, which essentially finds features in the image. The camera captures it, and it finds corners and features and keeps them in a list. Once you have them, you can see the differences between the previous and next frame and where things have moved, so you can tell the difference in your position. You can run the bundle adjustment and reconstruct the 3D world from it. You can also combine it with gyroscope and sensor pose to give you right position for VR. With that type of technology, you can suddenly have devices which don't require external hardware. Of course, ultimately, you'd like to get to something called mixed reality, which is essentially the idea that you could be in a room and you could see your furniture from a real world combined with the augmented objects. You can also see people. The question is, how do you do that? Well, there's various technologies developing for it. Ideally, you'd like to have body tracking. So there are different ways of doing it. One particular, which was kind of commercially released by Microsoft, was Kinect, which used an IR projector and used cameras to get the image and do it from depth. Again, this is a computer vision problem. The way a type of a solution can work is reconstruct depths from a pattern image. Once you do that, you can get a point cloud for things in space. And from a point cloud, you do segmentation, and you can have an AI algorithm that is trained to handle different body poses. Essentially, you feed the algorithm a collection of a world of different situations. It memorizes it and is able to make those judgments later. And then you can use that to render real skeleton animation or interact with the real world. This is the type of technology we want to see more of in the near future. Now, the big story I mentioned, the second part of a big story, is AI. AI is a number of different things, but you can say that computer vision is actually part of AI. This means recognizing the environment through learning. Second part is human-computer interaction. It is assistance with everyday worlds. Once in the future, we'll have AI, which will be able to answer questions that you ask based on your context. It will know where you are. It will know what's going on around and what maybe your intentions are in some circumstances. And it'll be able to help you out. It'll be able to assist work in your life. It'll bring up your documents for you when you go into a lecture. It will do things automatically. And the amount of progress in AI recently has been fascinating. Now, this was a slide from the Facebook F8, where they presented work Facebook has been doing in an algorithm called masked RCNN, which is essentially a neural network approach to understanding images. If you look at this back in 2012, you had an image of a character of a woman and a dog. And it could basically tell that it was a person. Later on, in 2015, you could actually start defining shapes. where you could say there's a refrigerator in the back with a dog, and the person actually see where what is. By 2017, today, you could have accurate images knowing what it is, and you could also be able to model a skeleton and figure out which pose a person is taking. Having this type of technology available for augmented reality is very helpful. So this kind of brings us to another interesting part of the story. And this is what Mark talked about at F8, was the idea of camera as an augmented reality device. Today, we have all these things our phones can do. It can have stickers over top of images. You can do style transfer. You can know your location, so you can play Pokemon. And you can have notes and games in 3D, as well as other things. Now, all of these things, in some way, may seem easy, but there's actually challenging parts to them. So for example, in games, you may want to have 3D objects around the environment. How do you know where to put them? This is augmented reality. So therefore, you have to run these algorithms, so you have to reconstruct and figure out what's going on. So this is the same technology we are going to need to get to the glasses. So essentially, what we could start with doing it is by exposing these techniques in software and having them work on a phone, so that in the future, they can run in AR. So you can sort of see how all of these things are coming together. Computer vision, AI, and parts of them are available today. So we can start building and relying on it. So now let me talk briefly about development in VR. Basically, the question is, how do you do that if you wanted to start right now? So at the basic level, this is going to be oriented more towards software programmers. You have a core programming interface. For things like games, and many of you may be familiar with this, you have something called a game loop. You get your inputs, and then you run your simulation, and you render a scene. So you can sort of see it here. If you move your head, the data is transferred to a computer, which in simulation, it will process the positional tracking. It will try to simulate physics, where the objects are going. After it has done simulation, it can render the scene, which is usually done on a graphics chip or GPU. Today, we have them on mobile phones as well. And then you get your output in the glasses. So in virtual reality, all of it has to happen very quickly at 90 hertz and with low latency. So for that reason, VR headsets expose programming interfaces in C and C++. You can get your pose, which is which way you're looking and where you are, as well as other states, like which buttons are pressed on a controller. So once you get the data from this for the input, you can use it for rendering. Typically in graphics, you use OpenGL or Direct3D to do graphics rendering. These APIs provide access to your graphics hardware. And of course, to do this, you do need to know 3D, which is coordinate systems, transforms, some math, and things like that. You can find good books on it online. Now, an alternative to writing in C++ and OpenGL, you can pick one of the game engines. Two popular ones I'll mention are Unreal Engine and Unity. So Unreal has been around for a long time. It makes some of the most visually intense scenes. So when we had the dinosaur walking in our first Oculus demo, which kind of attacks you, that was done with Unreal Engine. A Unity engine is very popular right now because it is very easy to use, and it can still do a lot. You can program in C#, which is easier, and make things visually. Now, if you don't want to go all the way into programming, another thing you might be able to do is create 360 experiences in video. 360 videos have been popular since DK1, and they've really been enjoyed by filmmakers. There's a lot of people in Hollywood and other things who would like to be able to do 360 capture. So in fact, one of the first demos we shipped in Oculus was Felix and Paul. It was acrobats kind of around you. You'd look around, and you felt like you were there, even though it was really just a 360 image. Typically, this works through something called equirectangular projection, which is basically the idea you have this image which is mapped to a sphere around you. There's other ways of doing it, too. Now, when you do this, resolution is important. It's kind of the thing with VR, is that if you have a screen in front of you, and let's say it has, I don't know, an iPhone, couple thousand pixels, it's stretched to a small piece. Now, if you blow it up to a whole sphere of your view, you need a lot more pixels. So you need to have good cameras. Recently, Facebook announced its own design called Surround 360, which essentially puts either 24 or 6 cameras around to let you capture it. There's other 360 capture devices available as well. Now, as exciting as 360 is, an important thing is it doesn't have depth. And you really want to have depth in your image, because if you don't have it, you can only look around. For depth, you want to move left and right. With Facebook 360 Surround, they've actually wrote some algorithms which lets you extrapolate and compute depths based on data. There's also interesting light field technologies which are coming about, which lets you capture light from different angles per pixel. It's a very developing area, but one of the big things I think next in film and video is going to be this ability to capture more than just a flat image. So another alternative, and this is a project I've been working on for the last year, is actually WebVR. This is the idea of combining web technology in a browser with virtual reality. It wasn't really started at Oculus. It actually had roots in Mozilla's and Google's initiatives, making something called WebVR API. But we got involved and helped accelerate this over the last year. So at the very basic, the idea is that you could use JavaScript and WebGL plus something called the WebVR API to write content which runs in a web browser. Now, there's a lot more JavaScript programmers there than there are C++ ones. So this is easier to do. And the content would run on any device including PC, Mac, iOS, and VR headsets. So this kind of creates an opportunity where you can make VR content, or content which works in a headset, which also is available to billions of other users. So the idea is if you are on a PC, you can use a mouse to look around. If you have a phone, you can move it and use a gyroscope. If you're on a VR headset, you get the best experience because you really are in there. So this gives you a few other good things. It's easy to build. It's cross-platform, which we talked about. And instant on. You don't need to download an app. You can just go to a website with VR in it. So on the Oculus side and Facebook, we developed something called React VR. So for us, the initiative had to do with making a browser, which you can see in Gear VR, you can run, and it can bring pages in front of you, or it can create virtual worlds. Or you can program in this thing called React VR, which is really a framework for making things with tags and JavaScript. And a very basic, if you use something like React, you would have an environment built out of 3 components. There is the sphere, which covers the world. So you can have a background. It could be a video. It could be something else. You have 2D UI panels, which is text. And then you have 3D objects. So as an example, if you wanted to describe a scene with a background and a text panel, it could look something like this. You'd have a render function. You declare the panel, which contains your image. And inside of it, there is hello world and the image. I won't go more into details of this, but you can see how this makes it easier to make simple experiences. So of course, you have to choose the right tool for what you're trying to do. So to summarize, here are some of the ways you can do VR from easiest to kind of more involved. 360 experiences are great if you just want to do capture or share existing scenes. WebVR is easy if you have some web programming experience and some 3D, but are not making something very involved. It could be easy to get people to access this content. You use game engines for 3D scenes and something more advanced. And then you can program to the direct C++ SDKs if you want to make something really custom, or you have your own engine. So basically, that's it. Thank you. And I'm happy to answer any questions you have.